Have you ever paused to ponder why nitrogen and oxygen, the two most abundant gases in our atmosphere, exhibit such different reactivity profiles? The answer lies in their energy level diagrams, the maps of the atomic territory that guide electron behavior. Picture nitrogen, if you will. It's the seventh element on the periodic table and has 5 electrons in its outer energy level. Now let's break down its energy level diagram. The first energy level, closest to the nucleus, has 2 electrons in the 1s orbital. The second energy level holds the remaining 5 electrons, 2 in the 2s orbital and 3 in the 2p orbital. Here's the kicker. The 3 2p electrons each occupy their own orbital, following Hund's rule. This single occupancy configuration gives nitrogen a high degree of stability. Now imagine oxygen, the 8th element on the periodic table. It has 6 electrons in its outer energy level. In the first energy level, 2 electrons occupy the 1s orbital. The second energy level also has 2 distinct orbitals, the 2s and the 2p. 2 electrons fill the 2s orbital, and the remaining 4 electrons occupy the 2p orbital. Now here's where oxygen differs from nitrogen. Only 2 of the 2p orbitals each hold a single electron, while the third 2p orbital holds 2 electrons. This makes oxygen more reactive, as these paired electrons can often participate in chemical reactions. So, what's the big takeaway from all of this? Well, the energy level diagrams of nitrogen and oxygen provide a clear picture of why these two elements behave so differently. Nitrogen, with its single occupancy 2p orbitals, is stable and unreactive, while oxygen, with its one doubly occupied 2p orbital, is much more willing to react. In essence, these diagrams serve as a roadmap to understanding the behavior of atoms in chemical reactions. They offer a glimpse into the world of atoms, a world that may be tiny but is incredibly powerful. By examining these diagrams, you can predict how an atom will behave, and in doing so, you can better understand the world around you. So the next time you take a breath of fresh air, remember that the nitrogen and oxygen you're breathing in have their own unique energy level diagrams, and these diagrams are the key to understanding their behavior in our atmosphere and beyond.